The world's smallest carbon capture technology is launched. An industrial initiative to electrify EU crackers expands. Fish waste could be used for nylon production. New carbon capture technology simultaneously converts carbon dioxide. And a biotechnology demonstrator will produce acetone from captured industrial emissions.
Hey there, it's Chem Eng Weekly, and this is your month in review.
The world of chemical engineering is ever changing, and a lot of things happened in October 2021. But what were the biggest news stories? Make sure you watch till the end to get all of the latest news stories and the biggest impacts that they've had. Let's dive right into it. First of all, Wendy's are set to introduce plastic cups into all of their restaurants. Aiming to divert around £10 million worth of rubbish in the first 2 years, Wendy's, LyondellBasell and Berry Global have announced an initiative to replace all of Wendy's current cups with plastic cups. The reason the American fast food chain has taken this step is because currently Wendy's cups are contained with a thin layer of plastic inside the paper cups, which prevents the paper from going soggy. However, this presents problems when it comes to recyclability, because the cup is neither 100% paper nor 100% plastic. So less than 2% of Wendy's cups are currently recycled, with the rest going to landfill. To counteract this and make Wendy's a more eco-friendly enterprise, they have announced that they will be using plastic cups that are made from 20% recycled plastics, which LyondellBasell and Berry Global will provide to them, which they hope to roll out into all of their worldwide stores by 2023. A spokesperson for Wendy's said that the biggest problem with plastic is not the plastic itself, but how plastic waste is dealt with, and it is hoped that this move will allow for Wendy's to become more sustainable and set the future trend in terms of plastic cup usage. The world's smallest carbon capture technology has been launched. Cyclone CC, which is made by carbon capture technology experts Carbon Clean, is said to be the smallest carbon capture technology in the world, being fully installed and operational within 8 weeks due to the ease of transport and its small size. Backed by £5 million from the UK government, it is hoped that this technology will help the UK achieve its carbon neutrality targets by 2050 and be a major player in terms of making other countries also achieve their carbon neutrality targets. Right now, one of the biggest issues with carbon capture technology is its size, and with this major breakthrough, it is hoped that this will make carbon capture scalable, affordable, and more designable within larger processes. It works by using rotary bed pack technology, which is more efficient than the current chimney stack technology used for the absorption of carbon dioxide, and the company's proprietary amine-based solvent means that the carbon dioxide absorption to these pads within the technology will be done more smoothly, achieving a higher carbon capture rate and more efficiency overall. It has been successfully tested so far in the UK and the US, with companies such as Veolia and Lennox already commercializing it at 10 and 100 tonnes per day. The technology drives down the cost of carbon capture to around $30 per tonne, which is half the current EU carbon price per tonne. Being very economically viable, it is hoped to be rolled out worldwide by 2023. More partners have joined a scheme in the EU to electrify steam crackers. The consortium currently carrying out this initiative has welcomed Versalis and Repsol into its initiative to electrify steam crackers. The initiative is trying to replace fossil fuels that are currently being used within steam crackers with electricity that is more greenly produced and greenly sourced. But what is steam cracking? Steam cracking is a process by which long-chain hydrocarbons are split into small molecules that can be used as feedstocks, such as ethylene, propylene, benzene-containing compounds and more. These feedstocks are usually used in the next stage of other chemical processes, and therefore are vital to a number of different processes. As of right now, the current method involves pumping in a collection of long-chain hydrocarbons into a furnace at 850 degrees centigrade, where this temperature is achieved using burning from fossil fuels, with this temperature raise attributing to around 30 million tonnes of carbon dioxide produced a year, and it's a hope that this scheme will help to reduce this impact upon the environment. They will hope to achieve the high temperatures by using green hydrogen and other renewable sources of energy, whilst the feedstocks of the long-chain hydrocarbons themselves, although they are from fossil fuels, it is hoped that in the long term they can be replaced by more eco-friendly initiatives using biotechnology, such as pyrolysis from waste plastic production, as well as bio-naphtha from using biological techniques to create a circular economy. Researchers have developed a new form of carbon capture technology which captures and converts carbon dioxide into syngas simultaneously. The research has shown the viability of use of calcium oxide as both a sorbent and a catalyst, compared to the traditional methods of using a sorbent followed by a metal catalyst for the catalysis of the product. The current popular method captures the carbon dioxide onto the sorbent and then has the metal catalyst work as an absorption catalyst, whereby the carbon dioxide is bonded to it and the products are released. However, this new method is integrated carbon capture utilization, whereby a dual function material, in this case calcium oxide, will reduce the need for metal catalysts to be used, which are expensive and can be easily poisoned, giving a more efficient outcome overall. This new method feeds hydrogen into a reactor with carbon dioxide and the sorbent of calcium oxide, forcing it to react and creating a calcium carbonate bed. However, the use of hydrogen right now is not very eco-friendly because it's not sourced from renewable energy sources, and it's hoped that this issue will be overcome during the scale-up process. Nonetheless, this process has the positive of not needing to transport the captured carbon dioxide for it to be further processed, and it is viable because once the calcium oxide starts to reach its end of life, it can be sold off to the cement industry for use in cement processing. This will therefore create a zero-waste economy. A biotech demonstrator will produce acetone from captured industrial emissions in Norway. A consortium of Johnson Matthey, NORCE Norwegian Institute of Research, and Arsena have announced that a 44 million euros plant is set to be built in Norway that will demonstrate the production of acetone from industrial captured emissions. It is said that the Pyro CO2 project plant will convert captured carbon dioxide and renewably sourced hydrogen into acetone using a thermophilic microbial process, which will hope to produce around 4,000 tonnes of acetone a year. It is part of the EU's larger targets to reach carbon neutrality by 2050, with the hope that this process can be commercialised in the future to make sure that industrial emissions are put into the economy rather than put into the worries of climate change. With the project running until 2026, it is hoped that the acetone produced from this could be further catalyzed into other small products used for recyclable polymers and synthetic field chemicals, which could again help with the commercialization. In the long term, this has hopes to reduce greenhouse gas emissions. And finally, fish is being researched into for the production of nylon. Researchers in Scotland are exploring the viability of extracting adipic acid from fish waste compared to the traditional routes from petrochemicals. Adipic acid has many applications in a number of different fields, such as in the pharmaceutical field, in nylon production, and also furniture cushion creation, but currently has a high level of environmental impact. The research process would see biological enzymes attack fish waste and extract the adipic acid from here, and since fish waste accounts to 492,000 tonnes in the UK alone in a year, it's a very viable option given how this waste usually goes into fertilizer production and other low-grade animal feed products. Following on from the enzyme attack, bioengineered bacteria will process the fats left over into adipic acid, which could be processed into a number of useful byproducts. The collaborators on this project include plastic experts Impact Solutions, fine food company Labori, the Industrial Biotechnology Innovation Centre, as well as the University of Edinburgh doing the research. A spokesperson said that the remaining sludge after the adipic acid had been extracted is currently being researched into further, with the hope that it could yet extract further fish oils and other vitamins for use in the vitamin industry. And with that, we've covered the biggest news stories of October 2021. What did you make of them? Any other news stories that I've missed? Make sure you comment down below in the comment section. And with that comes the end of the video.
Thank you for watching the video. Be sure to like it if you enjoyed it, and leave your comments and suggestions down in the comment section below. Don't forget to follow us on our social media channels, and if you click here or here, you can watch another one of our videos. Click up here to subscribe, and thank you very much.